This is part 5 of the Unit 11 notes on water, aqueous systems, and solutions, and this is the solubility rules. In order to determine if a compound is soluble, you have to look at the composition of that compound. Compounds are typically composed of a positively charged atom or ion and a negatively charged atom or ion, which we call a cation and an anion. The positively charged atom or ion, like I said, is called a cation, and it's typically a metal. The negatively charged atom or ion is called an anion, and it can either be a nonmetal or a polyatomic ion. So here, Ag is my cation, and NO3 is my anion. Na is my cation, and C2H3O2, which is acetate, would be my anion. We have NH4, which is ammonium, would be my cation, and we have SO4, which is sulfate, it would be my anion. We have Fe, which is iron, it would be my cation, and Cl, which would be my anion. Then we have calcium, which would be my cation, and nitrate, which would be my anion. To determine if a substance is soluble or not soluble, you will use the solubility of common ionic compounds in water, and you'll use the chart that's on the back of your periodic table. So this is what we have on the back of our periodic table. This is acetate, this is ammonium, this is nitrate. Remember, all these polyatomic ions are listed also on the back of our periodic table right next to it. Nitrate, cyanide, hypochlorite, chlorite, chlorate, perchlorate, this would be bromide, chloride, iodide, sulfate, carbonate, phosphate, chromate, dichromate, hydroxide, and sulfide. Okay, so when we look at this, we can divide it into these are soluble, but if you come over here, this would mean that that's an exception, so it's insoluble, meaning it won't dissolve. And then these are insoluble, but these over here, since there's exceptions, would be soluble. Insoluble means it doesn't dissolve, which would mean it becomes a precipitate. All right. So AgNO3. So when we look at these, most of these are negatives to look at. So we will look at the NO3. We come up here to NO3. It is under the soluble list. We always go across. There are no exceptions of what can be combined with NO3 and still be soluble. So this compound would be soluble in water. Okay. For the next one, we're going to look up acetate because C2H3O2 is on here and Na positive is not. So again, anything combined with acetate doesn't matter. They're always going to be soluble. So this one is also soluble. For this next one, we have ammonium and sulfate. Well, ammonium is on here, and there are no exceptions. It should be soluble. And if we come down here to sulfate, and we go across, it says only if it's combined with strontium, barium, lead, or mercury is it insoluble. Well, it's combined with NH4, so that would make it soluble. So you could look up either one, and you would get the same answer. Then for FeCl, 3, Cl's the negative, Fe is nowhere on here, and it is soluble. But when we go over here, Ag and lead, so silver and lead and mercury, well, iron is not one of those, so that would mean that it is soluble. Then we have calcium nitrate, so we look up nitrate. Nitrate again combined with anything is soluble, so this will be soluble. Then zinc sulfate or sulfide, so we come over here to sulfide, and it's in the insolubles, but we have to double check it. So zinc is not NH4, zinc is not a alkali metal, because that's column 1A on your periodic table, and it's not calcium, strontium, or barium. So that would mean that it's going to stay in this column over here, so that is insoluble. So that would mean it wouldn't dissolve in water, or it wouldn't dissolve when we put it with another compound. It would become a solid. Barium chromate, so chromate is CrO4, so it's here in the insolubles, except for when it's with ammonium or an alkali metal. Barium is an alkali earth metal, so this is still insoluble. Magnesium sulfate, we look up sulfate. Magnesium is not an exception, so this would make this soluble. Sometimes when two compounds react with each other, they form completely different compounds, and some of which are soluble and others are insoluble. And that's, like I said, these reactions are double replacement reactions, and that's how we end up with one being a precipitate and the other being an aqueous solution. All right, we did these actual double replacement reactions in class and in demos on videos with remote. When we learned about reactions and double replacement reactions, we also did it at the very beginning of the year to prove when a chemical change had happened. So if I had AgNO3 added to K2CO3, which is silver nitrate and potassium carbonate, we would end up with silver carbonate and potassium nitrate. So we could look these up on our periodic table on the back, and when we look those up, we would see that CO3, when it's combined with Ag, is insoluble, and it would be the precipitate. Whereas if we look at NO3, potassium NO3 is soluble, so it would just be aqueous. Okay, if we do another one, we could look up the calcium phosphate and the potassium nitrate. Again, potassium nitrate is aqueous, but when we look up calcium phosphate, it is insoluble, so it would be a precipitate. All right, this concludes part 5 of Unit 11 and concludes the Unit 11 notes.